In this chapter, we're going to be taking a look at conversational memory in LangChain. We're going to be taking a look at the core chat memory components that have already been in LangChain since the start, but are essentially no longer in the library. And we'll be seeing how we actually implement those historic conversational memory utilities in the new versions of LangChain, so 0.3. Now, as a pre-warning, this chapter is fairly long, but that is because conversational memory is just such a critical part of chatbots and agents. Conversational memory is what allows them to remember previous interactions, and without it, our chatbots and agents would just be responding to the most recent message without any understanding of previous interactions within a conversations. So they would just not be conversational. And depending on the type of conversation, we might want to go with various approaches to how we remember those interactions within a conversation. Now, throughout this chapter, we're going to be focusing on these 4 memory types. We'll be referring to these, and I'll be showing you actually how each one of these works. But what we're really focusing on is rewriting these for the latest version of LangChain using what's called the RunnableWithMessageHistory. So we're going to be essentially taking a look at the original implementations for each of these 4 original memory types, and then we'll be rewriting them with the runnable memory history class. So just taking a look at each of these 4 very quickly. Conversational buffer memory is, I think, the simplest and most intuitive of these memory types. It is literally just you have your messages, they come into this object, they are stored in this object as essentially a list, and when you need them again, it will return them to you. There's nothing else to it. It's super simple. The conversation buffer window memory, okay, so new word in the middle there, window. This works in pretty much the same way, but those messages that it has stored, it's not going to return all of them for you. Instead, it's just going to return the most recent, let's say the most recent 3, for example. Okay, and that is defined by a parameter k. Conversational summary memory, rather than keeping track of the entire interaction memory directly, what it's doing is as those interactions come in, it's actually going to take them and it's going to compress them into a smaller little summary of what has been within that conversation. And as a new interaction is coming in, it's going to do that, going to keep iterating on that summary, and then that is going to be returned to us when we need it. And finally, we have the conversational summary buffer memory. So this is, so the buffer part of this is actually referring to a very similar thing to the buffer window memory, but rather than it being a most k messages, it's looking at the number of tokens within your memory, and it's returning the most recent k tokens. That's what the buffer part is there. And then it's also merging that with the summary memory here. So essentially what you're getting is almost like a list of the most recent messages based on the token length rather than the number of interactions, plus a summary, which would come at the top here. So you get kind of both. The idea is that obviously this summary here would maintain all of your interactions in a very compressed form. So you're losing less information and you're still maintaining, maybe the very first interaction, the user might have introduced themselves, giving you their name. Hopefully that would be maintained within the summary and it would not be lost. And then you have almost like a higher resolution on the most recent K or K tokens from your memory. Okay, so let's jump over to the code. We're going into the 04 chat memory notebook, open that in Colab. Okay, and here we are. Let's go ahead and install the prerequisites, run all. We, again, can or cannot use a LangSmith. It is up to you. Enter that, and let's come down and start. So first, just initialize our LLM using 40 mini. In this example, again, low temperature. And we're going to start with conversation buffer memory. Okay, so this is the original version of this memory type. So let me, where are we? We're here. So memory, conversation buffer memory, and we're returning messages that needs to be set to true. So the reason that we set return messages to true, as it mentions up here, is if you do not do this, it's going to be returning your chat history as a string to an LLM, whereas, well, chat LLMs nowadays would expect message objects. So yeah, you just want to be returning these as messages rather than as strings. Okay. Otherwise, yeah, you're going to get some kind of strange behavior out from your LLMs if you return them as strings. So you do want to make sure that it's true. I think by default, it might not be true, but this is coming. This is deprecated, right? It does tell you here as deprecation warning. This is coming from older LangChain, but it's a good place to start just to understand this. And then we're going to rewrite this with the runnables, which is the recommended way of doing so nowadays. Okay. So adding messages to our memory. We're going to write this. Okay, so it's just a conversation user, AI, so on and so on. Random chat. Main things to note here is I do provide my name. We have the model's name, right, towards the start of those interactions. Okay, so I'm just going to add all of those. We'll do it like this. Okay, then we can just see, we can load our history like so. So let's just see what we have there. Okay, so we have human message, AI message, human message, right? This is exactly what I showed you just here. It's just in that message format from LangChain. Okay, so we can do that. Alternatively, we can actually do this. So we can get our memory. We initialize the conversational buffer memory as we did before, and we can actually add it directly, each message into our memory like that. So we can use this add user message, add AI message, so on and so on, load again, and it's going to give us the exact same thing. Again, there's multiple ways to do the same thing. Cool. So we have that. To pass all of this into our LLM, again, this is all deprecated stuff we're going to learn how to use properly in a moment, but this is how LangChain was doing it in the past. So to pass all of this into our LLM, we'd be using this conversation chain, right? Again, this is deprecated. Nowadays, we would be using LCEL for this. So I just want to show you, okay, how this would all go together. And then we would invoke, okay, what is my name again? Let's run that and we'll see what we get. It's remembering everything, remember? So this conversation buffer memory, it doesn't drop messages. It just remembers everything, right? And honestly, with the sort of high context windows of many LLMs, that might be what you do. It depends on how long you expect a conversation to go on for, but you probably, in most cases, would get away with this. Okay, so let's see what we get. I say, what is my name again? Okay, and let's see what it gives me. It says your name is James. Great, thank you. That works. Now, as I mentioned, all of this that I just showed you is actually deprecated. That's the old way of doing things. Let's see how we actually do this in modern or up-to-date LangChain. So we're going to be using this RunnableWithMessageHistory. To implement that, we will need to use LCEL. And for that, we will need to just define prompt templates, our LLM, as we usually would. Okay, so we're going to set up our system prompt, which is just your helpful assistant called Zeta. Okay, we're going to put in this messages placeholder. Okay, so that's important. Essentially, that is where our messages that are coming from our conversation buffer memory is going to be inserted, right? So it's going to be, that chat history is going to be inserted after our system prompt, but before our most recent query, which is going to be inserted last here. Okay, so messages placeholder item, that's important. And we use that throughout the course as well. So we use it both for chat history, and we'll see later on, we also use it for the intermediate thoughts that an agent would go through as well. So important to remember that little thing. We'll link our prompt template to our LLM. Again, if we would like, we could also add in I think we only have the query here. Oh, we would probably also want our history as well, but I'm not going to do that right now. Okay, so we have our pipeline, and we can go ahead and actually define our runnable with message history. Now, this class or object, when we are initializing it, does require a few items. We can see them here. Okay, so we see that we have our pipeline with history. So it's basically going to be, you can see here, right? We have that history messages key, right? This here has to align with what we provided as the messages placeholder in our pipeline, right? So we have our pipeline prompt template here and here, right? So that's where it's coming from. It's coming from messages placeholder. The variable name is history, right? That's important. That links to this. Then for the input messages key here, we have query. That, again, links to this. Okay, so both important to have there. The other thing that is important is obviously we're passing in that pipeline from before, but then we also have this get session history. Basically what this is doing is it's saying, okay, I need to get the list of messages that make up my chat history that are going to be inserted into this variable. So that is a function that we define. Okay, and within this function, what we're trying to do here is actually replicate what we have with the previous conversation buffer memory. Okay, so that's what we're doing here. So it's very simple, right? So we have this in-memory chat message history. Okay, so that's just the object that we're going to be returning. What this will do is it will set up a session ID. The session ID is essentially like a unique identifier so that each conversation or interaction within a single conversation is being mapped to a specific conversation. So you don't have overlapping, let's say you have multiple users using the same system. You want to have a unique session ID for each one of those. Okay. And what it's doing is saying, okay, if the session ID is not in the chat map, which is this empty dictionary we defined here, we are going to initialize that session with an in-memory chat message history. Okay. And that's it. We return. Okay, and all that's going to do is it's going to basically append our messages. They will be appended within this chat map session ID, and they're going to get returned. There's nothing else to it, to be honest. So we invoke our runnable. Let's see what we get. Oh, I need to run this. Okay, note that we do have this config, so we have a session ID. That's to, again, as I mentioned, keep different conversations separate. Okay, so we've run that. Now let's run a few more. So what is my name again? Let's see if it remembers. Your name is James. How can I help you today, James? Okay, so it's what we've just done there is literally conversation buffer memory, but for up-to-date LangChain with LCEL with runnables. So, you know, the recommended way of doing it nowadays. So that's a very simple example. Okay, there's really not that much to it. It gets a little more complicated as we start thinking about the different types of memory. Although with that being said, it's not massively complicated. We're only really going to be changing the way that we're getting our interactions. So let's dive into that and see how we will do something similar with the conversation buffer window memory. But first, let's actually just understand, okay, what is the conversation buffer window memory? So as I mentioned near the start, it's going to keep track of the last K messages. So there's a few things to keep in mind here. More messages does mean more tokens sent with each request. And if we have more tokens in each request, it means that we're increasing the latency of our responses and also the cost. So with the previous memory type, we're just sending everything. And because we're sending everything, that is going to be increasing our costs, it's going to be increasing our latency for every message, especially as the conversation gets longer and longer. And we might not necessarily want to do that. So with this conversation buffer window memory, we're going to just say, okay, just return me the most recent messages. Okay. So let's see how that would work. Here, we're going to return the most recent 4 messages. Okay, we are, again, make sure we return messages is set to true. Again, this is deprecated. This is just the old way of doing it. In a moment, we'll see the updated way of doing this. We'll add all of our messages. Okay, so we have this. And just see here, all right? So we've added in all these messages. There's more than 4 messages here. And we can actually see that here. So we have human message, AI, human, AI, human, AI, human, AI, right? So we've got 4 pairs of human AI interactions there. But here we don't have, there's more than 4 pairs. So 4 pairs would take us back all the way to here. I'm researching different types of conversational memory. Okay, and if we take a look here, the first message we have is I'm researching different types of conversational memory. So it's cut off these two here, which will be a bit problematic when we ask you what our name is. Okay, so let's just see. We're going to be using conversation chain object again. Just remember that is deprecated. And I want to say, what is my name again? Let's see what it says. I'm sorry, but I don't have access to your name or any personal information. If you like, you can tell me your name. Right, so it doesn't actually remember. So that's kind of like a negative of the conversation buffer window memory. Of course, to fix that in this scenario, we might just want to increase K. Maybe we say remember the previous 8 interaction pairs, and it will actually remember. So what is my name again? Your name is James. So now it remembers. We've just modified how much it is remembering. But of course, there's pros and cons to this. It really depends on what you're trying to build. So let's take a look at how we would actually implement this with the RunnableWithMessageHistory. Okay. So, getting a little more complicated here, although it's not complicated, but well, we'll see. Okay, so we have buffer window message history. We're creating a class here. This class is going to inherit from the base chat message history object from LangChain. Okay, and all of our other message history objects can do the same thing. Before, with the in-memory message object, that was basically replicating the buffer memory. So we didn't actually need to do anything. We didn't need to define our own class here. So in this case, we do. So we follow the same pattern that LangChain follows with this base chat message history. And you can see a few of the functions here that are important. So add messages and clear are the ones that we're going to be focusing on. We also need to have messages, which is this object attribute here. Okay, so we're just implementing the synchronous methods here. If we want this to be async, if we want to support async, we would have to add messages, get messages, and clear as well. So let's go ahead and do that. We have messages, we have K. Again, we're looking at remembering the top K messages or most recent K messages only. So it's important that we have that variable. We are adding messages through this class. This is going to be used by LangChain within our runnable. So we need to make sure that we do have this method. And all we're going to be doing is extending the self messages list here. And then we're actually just going to be trimming that down so that we're not remembering anything beyond those, most recent K messages that we have set from here. And then we also have the clear method as well. So we need to include that. That's just going to clear the history. Okay. So this isn't complicated, right? It just gives us this nice default standard interface for message history. And we just need to make sure we're following that pattern. Okay. I've included this print here just so we can see what's happening. Okay, so we have that. And now for that get chat history function that we defined earlier, rather than using the built-in method, we're going to be using our own object, which is a buffer window message history, which we defined just here. Okay, so if session ID is not in the chat map as we did before, we're going to be initializing our buffer window message history. We're setting K up here with a default value of 4, and then we just return it. Okay, and that is it. So let's run this. We have our runnable with message history. We have all of these variables, which are exactly the same as before, but then we also have these variables here with this history factory config. And this is where, if we have new variables that we've added to our message history, in this case, K that we have down here, we need to provide that to LangChain and tell it this is a new configurable field. Okay. And we've also added it for the session ID here as well. So we're just being explicit and have everything in there. So we have that and we run. Okay. Now let's go ahead and invoke and see what we get. Okay. So important here, this history factory config, that is kind of being fed through into our invoke so that we can actually modify those variables from here. Okay, so we have config, configurable, session ID. Okay, we'll just put whatever we want in here. And then we also have the number K. Okay, so remember the previous 4 interactions. I think in this one, we're doing something slightly different. I think we're remembering the 4 interactions rather than the previous 4 interaction pairs. Okay, so my name is James. We're going to go through, I'm just going to actually clear this, and then I'm going to start again, and we're going to use the exact same add user message, add AI message that we used before. We're just manually inserting all that into our history so that we can then just see, okay, what is the result? And you can see that k equals 4 is actually, unlike before where we were having the saving the top 4 interaction pairs, we're now saving the most recent 4 interactions, not pairs, just interactions. And honestly, I just think that's clearer. I think it's weird that the number 4 for k would actually save the most recent 8 messages, right? I think that's odd. So I'm just not replicating that weirdness. We could if we wanted to. I just don't like it, so I'm not doing that. And anyway, we can see from messages that we're returning just the most 4 recent messages, okay? Which would be these 4. Okay, cool. So we've just, using the runnable, we've replicated the old way of having a window memory. And okay, I'm going to say, what is my name again? As before, it's not going to remember. So we can come to here. I'm sorry, but I don't have access to personal information, and so on and so on. If you like to tell me your name, it doesn't know. Now let's try a new one where we initialize a new session. Okay, so we're going with ID K14, so that's going to create a new conversation there. And we're going to say, we're going to set K to 14. Okay, great. I'm going to manually insert the other messages as we did before. Okay, and we can see all of those. You can see at the top here, we are still maintaining that hi, my name is James message. Now let's see if it remembers my name. Your name is James. Okay, there we go. Cool, so that is working. We can also see, so we just added this. What is my name again? Let's just see if did that get added to our list of messages, right? What is my name again? Nice. And then we also have the response, your name is James. So just by invoking this, because we're using the runnable with message history, it's just automatically adding all of that into our message history, which is nice. Cool. All right, so that is the buffer window memory. Now we are going to take a look at how we might do something a little more complicated, which is the summaries, okay? So when you think about the summary, what are we doing? We're actually taking the messages, we're using the LM call to summarize them, to compress them, and then we're storing them within messages. So let's see how we would actually do that. So to start with, let's just see how it was done in old LangChain. So we have ConversationSummaryMemory. Go through that. And let's just see what we get. So again, same interactions, right? I'm just invoking. I'm not adding these directly to the messages because it actually needs to go through a, like that summarization process. And if we have a look, we can see it happening. Okay, current conversation. So, sorry, current conversation. Hello there, my name is James. AI is generating. Current conversation. The human introduces himself as James. AI greets James warmly and expresses its readiness to chat and assist, inquiring about how his day is going. Right, so it's summarizing the previous interactions. And then we have, after that summary, we have the most recent human message, and then the AI is going to generate its response. Okay, and that continues going. And you can see that the final summary here is going to be a lot longer. Okay, and it's different to that first summary, of course. Asking about his day, he mentioned stage of researching different types of conversational memory. The AI responds enthusiastically, explaining that conversational memory includes short-term memory, long-term memory, contextual memory, personalized memory, and then inquires if James is focused on a specific type of memory. Okay, cool. So we get essentially the summary is just getting longer and longer as we go. But at some point, the idea is that it's not going to keep just growing, and it should actually be shorter than if you were saving every single interaction whilst maintaining as much of the information as possible. But of course, you're not going to maintain all of the information that you would with, for example, the buffer memory, right? With the summary, you are going to lose information, but hopefully less information than if you were just cutting interactions. So you're trying to reduce your token count whilst maintaining as much information as possible. Now, let's go and ask, what is my name again? It should be able to answer because we can see in the summary here that I introduced myself as James. Okay, response, your name's James. How is your research going? Okay, so how's that? Cool, let's see how we'd implement that. So again, as before, we're going to go with that conversation summary message history. We're going to be importing a system message. We're going to be using that not for the LLM that we're chatting with, but for the LLM that will be generating our summary. So actually, that is not quite correct. There's create a summary. Not that it matters, it's just the doc string. So we have our messages and we also have the LLM. So different attribute here to what we had before. When we initialize a conversation summary message history, we need to be passing in our LLM. We have the same methods as before. We have add messages and clear. And what we're doing is as messages come in, we extend with our current messages, but then we're modifying those. Okay, so we construct our instructions to make a summary. Okay, so that is here. We have the system prompt, given the existing conversation summary and the new messages, generate a new summary of the conversation, ensuring to maintain as much relevant information as possible. Okay, then we have a human message here. Through that, we're passing the existing summary. Okay, and then we're passing in the new messages. Okay, cool. So we format those and invoke the LLM here. And then what we're doing is in the messages, we're actually replacing the existing history that we had before with a new history, which is just a single system summary message. Okay, and let's see what we get. As before, we have that get chat history exactly the same as before. The only real difference is that we're passing in the LLM parameter here. And of course, as we're passing in the LLM parameter in here, it does also mean that we're going to have to include that in the configurable field spec. And that we're going to need to include that when we're invoking our pipeline. Okay, so we run that, passing in the LLM. Now, of course, one side effect of generating summaries for everything is that we're actually, we're generating more. So you are actually using quite a lot of tokens. Whether or not you are saving tokens or not actually depends on the length of a conversation. As the conversation gets longer, if you're storing everything, after a little while, that the token usage is actually going to increase. So if in your use case, you expect to have shorter conversations, you would be saving money and tokens by just using the standard buffer memory. Whereas if you're expecting very long conversations, you would be saving tokens and money by using the summary history. Okay, so let's see what we got from there. We have a summary of the conversation. James introduced himself by saying, "Hi, my name is James." AI responded warmly, asking, "Hi, James." And interaction included details about token usage. Okay, so we actually included everything here, which we probably should not have done. Why did we do that? So in here, we're including all of the including all of the content from the messages. So I think maybe if we just do x.content for x in messages, that should resolve that. Okay, there we go. So we quickly fix that. So yeah, before we were passing in the entire message object, which obviously includes all of this information, whereas actually we just want to be passing in the content. So we modified that, and now we're getting what we'd expect. Okay, cool. And then we can keep going, right? So as we keep going, the summary should get more abstract. As we just saw here, is literally just giving us the messages directly almost. Okay, so we're getting a bit of a summary there, and we can keep going. We're going to add just more messages to that. We'll see the, as we'll send those, we'll get a response, send it again, get a response. We're just adding all of that, invoking all of that, and that will be, of course, adding everything into our message history. Okay, cool. So we've run that. Let's see what the latest summary is. Okay, and then we have this. So this is the summary that we have instead of our chat history. Okay, cool. Now, finally, let's see what's my name again. We can just double check. It has my name in there, so it should be able to tell us. Okay, cool. So your name is James. Pretty interesting. So let's have a quick look over at LangSmith. So the reason I want to do this is just to point out, okay, the different essentially token usage that we're getting with each one of these. Okay, so we can see that we have these RunnableWithMessageHistory, which is probably improved in naming there. But we can see, okay, how long is each one of these taken? How many tokens are they also using? If we come back to here, we have this RunnableWithMessageHistory. This is, we'll go through a few of these, maybe to here, I think. And we can see here, this is that first interaction where we're using the buffer memory. And we can see how many tokens were used here. So 112 tokens when we're asking, what is my name again? Okay. Then we modified this to include, I think it was like 14 interactions or something along those lines. It obviously increases the number of tokens that we're using, right? So we could see that actually happening all in LangSmith, which is quite nice. And we can compare, okay, how many tokens is each one of these using? Now, this is looking at the buffer window. And then if we come down to here and look at this one, so this is using our summary. Okay, so our summary with what is my name again, actually use more tokens in this scenario, right? Which is interesting because we're trying to compress information. The reason there's more is because there hasn't been that many interactions. As the conversation length increases with the summary, this total number of tokens, especially if we prompt it correctly to keep that low, that should remain relatively small. Whereas with the buffer memory, that will just keep increasing and increasing as the conversation gets longer. So useful little way of using LangSmith there to just kind of figure out, okay, in terms of tokens and costs, what we're looking at for each of these memory types. Okay, so our final memory type acts as a mix of the summary memory and the buffer memory. So what it's going to do is keep the buffer up until an n number of tokens. And then once a message exceeds the n number of token limit for the buffer, it is actually going to be added into our summary. So this memory has the benefit of remembering in detail the most recent interactions, whilst also not having the limitation of using too many tokens as a conversation gets longer and even potentially exceeding context windows if you try super hard. So this is a very interesting approach. Now, as before, let's try the original way of implementing this. Then we will go ahead and use our update method for implementing this. So we come down to here and we're going to do LangChain memory import conversation summary buffer memory. Okay, a few things here. LLM for summary. We have the n number of tokens that we can keep before they get added to the summary. And then return messages, of course. Okay, you can see again, this is deprecated. We use the conversation chain and then we just pass in our memory there and then we can chat. Okay, so super straightforward. First message, we'll add a few more here. Again, we have to invoke because our memory type here is using an LM to create those summaries as it goes. And let's see what they look like. Okay, so we can see for the first message here, we have a human message and then an AI message. Then we come a little bit lower down. Again, it's the same thing. Human message is the first thing in our history here. Then it's a system message. So this is at the point where we've exceeded that 300 token limit and the memory type here is generating those summaries. So that summary comes in as a system message. And we can see, okay, the human named James introduces himself and mentions he's researching different types of conversational memory and so on, right? Okay, cool. So we have that. Then let's come down a little bit further. We can see, okay, so the summary there. Okay, so that's what we have. That is the implementation for the old version of this memory. Again, we can see it's deprecated. So how do we implement this? for our more recent versions of LangChain, and specifically 0.3. Well, again, we're using that runnable with message history, and it looks a little more complicated than we were getting before, but it's actually just, it's nothing too complex. We're just creating a summary as we did with the previous memory type, but the decision for adding to that summary is based on, in this case, actually the number of messages. So I didn't go with the LangChain version where it's a number of tokens. I don't like that. I prefer to go with messages. So what I'm doing is saying, okay, the last K messages, okay? Once we exceed K messages, the messages beyond that are going to be added to the memory. Okay, cool. So let's see. We first initialize our conversation summary buffer message history class with LM and K. Okay, so these two here. So LM, of course, to create summaries, and K is just the limit of the number of messages that we want to keep before adding them to the summary, or dropping them from our messages and adding them to the summary. Okay, so we will begin with, okay, do we have an existing summary? So the reason we set this to none is we can't extract the summary, the existing summary, unless it already exists. And the only way we can do that is by checking, okay, do we have any messages? If yes, we want to check if within those messages we have a system message, because we're doing the same structure as what we have up here, where the system message, that first system message, is actually our summary. So that's what we're doing here. We're checking if there is a summary message already stored within our messages. Okay. So we're checking for that. If we find it, we have this little print statement so we can see that we found something. And then we just make our existing summary. I should actually move this to the first instance here. Okay, so that existing summary will be set to the first message. Okay, and this would be a system message rather than a string. Cool, so we have that. Then we want to add any new messages to our history. Okay, so we're extending the history there. And then we're saying, okay, if the length of our history exceeds the K value that we set, we're going to say, okay, we found that many messages. We're going to be dropping the latest. It's going to be the latest 2 messages. This, I will say here, one thing or one problem with this is that we're not going to be saving that many tokens if we're summarizing every 2 messages. So what I would probably do is in an actual like production setting, I would probably say, let's go up to 20 messages. And once we hit 20 messages, let's take the previous 10. We're going to summarize them and put them into our summary alongside any previous summary that already existed. But in this is also fine as well. Okay, so we say we found those messages. We're going to drop the latest 2 messages. Okay, so we pull the oldest messages out. I should say not the latest, it's the oldest. Not the latest. We want to keep the latest, drop the oldest. So we pull out the oldest messages and keep only the most recent messages. Okay. Then I'm saying, okay, if we don't have any old messages to summarize, we don't do anything, we just return. Okay, so this indicates that this has not been triggered. We would hit this. But in the case this has been triggered and we do have old messages, we're going to come to here. Okay, so this is, we can see, we have a system message prompt template saying, given the existing conversation summary and the new messages, generate a new summary of the conversation, ensuring to maintain as much relevant information as possible. So if we want to be more conservative with tokens, we could modify this prompt here to say, keep the summary to within the length of a single paragraph, for example. And then we have our human message prompt template, which is going to say, okay, here's the existing conversation summary and here are new messages. Now, new messages here is actually the old messages, but the way that we're framing it to the LLM here is that we want to summarize the whole conversation, right? It doesn't need to have the most recent messages that we're storing within our buffer. It doesn't need to know about those. That's irrelevant to the summary. So we just tell it that we have these new messages. And as far as this LLM is concerned, this is like the full set of interactions. Okay, so then we would format those and invoke our LLM. And then we'll print out our new summary so we can see what's going on there. And we would prepend that new summary to our conversation history. Okay, and this will work, so we can just prepend it like this because we've already popped, where was it? Up here. If we have an existing summary, we already popped that from the list, so it's already been pulled out of that list. So it's okay for us to just, we don't need to say like, we don't need to do this because we've already dropped that initial system message if it existed. Okay, and then we have the clear method as before. So that's all of the logic for our conversational summary buffer memory. We redefine our get chat history function with the LM and K parameters there. And then we'll also want to set the configurable fields again. So that is just going to be, of course, session ID, LM, and K. Okay, so now we can invoke the K value to begin with is going to be 4. Okay, so you can see no old messages to update summary with. That's good. Let's invoke this a few times and let's see what we get. Okay, so no old messages to update summary with. Found 6 messages, dropping the oldest 2. And then we have new summary. In the conversation, James introduced himself and first was interested in researching different types of conversational memory. Right, so you can see there's quite a lot in here at the moment. So we would definitely want to prompt the LLM, the summary LLM, to keep that short. Otherwise, we're just getting a ton of stuff, right? But we can see that that is, you know, it's working, it's functional. So let's go back and see if we can prompt it to be a little more concise. So we come to here, ensuring to maintain as much relevant information as possible. However, we need to keep our summary concise. The limit is a single short paragraph. Okay, something like this. Let's try and let's see what we get with that. Okay, so message 1, again, nothing to update. See this? So new summary, you can see it's a bit shorter. It doesn't have all those bullet points. Okay, so that seems better. Let's see. So you can see the first summary is a bit shorter, but then as soon as we get to the second and third summaries, the second summary is actually slightly longer than the third one. Okay, so we're going to be losing a bit of information in this case, more than we were before, but we're saving a ton of tokens. So that's, of course, a good thing. And of course, we could keep going and adding many interactions here. And we should see that this conversation summary will be, you know, it should maintain that sort of length of around 1 short paragraph. So that is it for this chapter on conversational memory. We've seen a few different memory types. We've implemented their old deprecated versions so we can see what they were like. And then we've re-implemented them for the latest versions of LangChain. And to be honest, using logic where we are getting much more into the weeds. And that is, in some ways, okay, it complicates things, that is true. But in other ways, it gives us a ton of control. So we can modify those memory types as we did with that final summary buffer memory type. We can modify those to our liking, which is incredibly useful when you're actually building applications for the real world. So that is it for this chapter. We'll move on to the next one.